Plan quality management is the process of identifying quality requirements and/or the standards for the project and its deliverables. It's also concerned with documenting how the project will demonstrate compliance with quality requirements and/or standards. The primary output here is the quality management plan, which again is the answer to the how question. How are we going to do all the other processes within the project quality management knowledge area? There are a number of quality management methodologies that may appear on your exam that we are going to discuss at a very high level. Six Sigma is a methodology that seeks to improve the quality of process outputs by identifying and removing causes of defects and minimizing variability in various processes. Each project should have a defined sequence of steps and a quantified efficiency target. If we think about a process in very simplistic terms, such as baking a cake, we have specific inputs that must be present before work can proceed, such as the cake mix, an egg, and some vegetable oil. We have specific tools and techniques that we require. Tools could include the mixing bowl, the whisk, the baking pan, and the oven. And the techniques are, well, how long are we going to stir everything together? What are we going to preheat the oven to? And how long are we going to cook that cake for? The output will be the cake. Obviously, the reduction in variability will have an impact on the output being consistently acceptable to the customer. If we don't consistently preheat that oven to 350 degrees, or if we don't cook it long enough, or perhaps if we cook the cake for too long, or if we add too much vegetable oil, or if we just skip putting an egg in it altogether, these can have effects that can lead to a product being rendered defective. By making sure that we are, as much as possible, minimizing, if not eliminating, that variability, we're increasing the likelihood that that output will be acceptable. Lean Six Sigma follows a similar path. The big difference here is instead of looking at variability within processes, we're looking at waste that exists within the processes. There's 7 specific types of waste that Lean Six Sigma seeks to eliminate. These are represented within the acronym TIM-WOOD. Transportation is considered a type of waste if we are moving a product from one location to another. By virtue of moving a product from one location to another, no value has been added to that product. So as much as possible, we want to reduce transportation to the minimal amount necessary. Inventory is considered a type of waste because we have spent money to purchase something that is not actively being used to generate value for the organization. Think about this as being like food in your pantry or clothing that you purchase but then don't wear. When we discuss waiting as a type of waste, this refers to practitioners that are being paid but are not producing anything of value. Perhaps they're waiting for somebody upstream to complete their work so that way they can go ahead and do their piece. If we visualize this along a production line, we can see how a choke point can cause several people to be waiting for any type of work to reach them. Overproduction simply means that we are producing more than the customer is willing to buy, accept, or consume. Overprocessing basically just means that we're putting more work into something than would be necessary. This is basically polishing something more than it needs to be polished. If we're told that we have to sweep a floor, then mopping, stripping, and buffing the floor would be considered overprocessing. Motion refers to an individual's motion within a process. So if we have a assembly line, if we are walking along it, or we have to walk 20 feet to get to a toolbox and another 30 feet to go get a spare part, that would be motion. As much as possible, we want to reduce the amount of motion that we have. And finally, defects. Defects are obviously a type of waste. When we have a defect, it does not necessarily render a product defective, which would be unacceptable to a customer, but it is something that is either going to detract value or require some degree of rework. Now, if a product is rendered defective, that's when we would most likely have to scrap it. There's 2 methodology approaches that we see with Six Sigma, and that is DMAIC and DMADV. The big difference between these two is at DMAIC, we're looking to improve an existing process, whereas DMADV, we're looking to design a new process. So we are either designing a process that does not exist currently, or we're designing a new process to replace one that we just want to get rid of altogether. Kanban is a method for managing knowledge work. This is very often used, especially in the software development realm. Just-in-time delivery is a very important aspect of Kanban, and this is something that is very relevant in many industries. When we think about the construction field, if we are building a skyscraper, it is very unlikely that we could have every steel girder or every sheet of glass delivered on the first day of the project. Or if we're having concrete delivered, obviously we cannot have that delivered in bulk because, well, it would get hard. We need to have it delivered exactly when we need it and where we need it. Another aspect of Kanban is not overloading the team members. The sustainability of pace becomes very important. Typically, they say that you should not work more than 80% of your day because if anything emergent should arise, you need that last 20% to go ahead and deal with it. Otherwise, those issues will spill over into nights and weekends, and the pace of work will become unsustainable. Kanban does use visual components such as whiteboards. Typically, they'll use a lot of post-it notes or cumulative flow diagrams. The visualization of work is very important. Limiting work in progress, again, not overloading the team. A focus on flow and continuous improvement are the major tenets of Kanban. Some best practices and standards in quality include the ISO 9000, and there's also some British standard equivalents to the ISO 9000. CMMI is something that was developed by Carnegie Mellon University to help assess vendor capabilities for the government when it came to software development procurement activities. There's 5 levels of CMMI. And again, if we think about this in terms of baking a cake as a very simplistic representation of process work, the initial level of CMMI is basically saying that we're making up the recipe as we go. If we have 5 practitioners, each one will bake that cake entirely differently, and even that individual, if we have one person bake 3 cakes, each one's going to be a little bit different. This is typical for organizations that don't do this type of work a whole lot. Now, for a managed process, this is where we have some type of process that has a loose framework almost, but it's going to be very reactive, and every project is going to tailor it to such an extent that it's going to be almost unrecognizable from one project to the next. By the time we get to a defined process, this is where the organization has some type of policy, procedure, process defined for this type of work. Now, the project can still go ahead and tailor or tweak in minor ways, but that process is still going to be recognizable. Within the PMBOK, we tend to call this an organizational process asset. This is something that we can take from that corporate knowledge base and use within our project. Quantitatively managed is where we are looking at processes and we are trying to improve their efficiency. The effectiveness is just whether or not the process can generate the end result that we desire. The efficiency becomes a concern with this quantitatively managed level here. So how much variance do we have within this process? What is the overall level of efficiency? And we're going to plug in key performance indicators to measure this. And finally, the 5th level is optimizing. This is where we have a singular focus on process improvement and trying to get that process to be as awesome as possible. Now, it's very important to note with these 5 levels, this is not an organizational measure. We're not saying that your organization is a level 3 defined. We're looking at individual processes that an organization uses. Typically within an organization, they'll have some processes that are absolutely great, and then you'll have some processes that are not, and they have a lot of room for improvement. The IEEE does have a number of quality standards as well that you can look into on their website, a number of technical standards. And quality function deployment. And this is something that is used very extensively within Six Sigma as part of the House of Quality, as we look at the voice of the customer, the voice of the business, and also sometimes the voice of the process. It's all about seeking out the customer needs and trying to figure out how can we best deliver on those needs. We have a note at the bottom of the slide. While this is not in the PMBOK, these methodologies are not in the PMBOK specifically, they are part of the exam content outline and may appear on your exam. So a very important quality concept. There are 5 increasing levels of effective quality management. The least effective level is letting customers find defects. If we visualize ourselves as sitting at a restaurant and we order food and they bring out your meal and it is just very poorly prepared and it is almost raw, it is not food safe. They're either going to have to compensate you in some way, or odds are we're going to get up and we're going to leave out of that restaurant. That's going to be the most expensive approach. It's going to result in lost business. It's going to result in some type of recall. It's going to result in all types of impacts that we really don't want to deal with. Detecting and correcting defects before the deliverables are sent to the customer, doing some type of quality control. This is good, however, it only allows us to find defects that already exist. Now, if we find a defect, we still have to do something to make it right. So it could be some type of rework, or we may have to throw it out. So if we're still using the example of a restaurant, if I'm cooking chicken, if that chicken is undercooked and I find that in an inspection, I have to do some rework and I have to cook it further. Now, if that chicken is overcooked, I may have to go ahead and scrap it. Either way, it's still a defect. The next level is actually using quality assurance to examine and correct the process itself. So this could be ensuring that we are cooking the chicken for the right amount of time, making sure that we have a process, and making sure that I'm abiding by that process. The next level is incorporating quality into planning and design. So perhaps when we're renovating the kitchen, we're ensuring that everything is being laid out in such a manner where it's difficult for me to get around and cook things improperly. Perhaps we have certain timers that we have set. So when you put chicken onto the grill, you hit a timer and suddenly now you know exactly how long it needs to be cooked for. Now, the most effective level of quality management is actually creating a culture that is both aware and committed to quality in both processes and products. This is where the practitioners are just as eager as management to ensure that quality is being built in to everything that's being done. Quality versus grade are concepts that are often used interchangeably, almost synonymously, which is incorrect. So for the purpose of the exam and within the PMBOK, quality is the degree to which a set of inherent characteristics fulfill requirements. Now, if you tell me that you're trying to cook a stew and you need carrots and potatoes and onions, if I go to the store and I get you carrots and potatoes and onions, then that would be high quality. I am fulfilling the requirements that you've given me. Now, if I get you a can of carrots for 33 cents at the store, you might look at me and say, well, I wanted fresh carrots. Well, okay. Well, but this can of carrots, this fulfills the requirements as you have given them to me. So this can of carrots is high quality. Now, grade is a category assigned to products or services having the same functional use, but different technical characteristics. So if we're talking about fresh organic carrots versus a can of diced carrots, both of them fulfill the requirements, but they're going to fulfill them in different ways. That fresh organic could be a higher grade, whereas that can of carrots is a lower grade, but both of them are high quality. Our focus as project managers is ensuring high quality. Grade is secondary concern. Prevention over inspection, we were discussing previously that if we are doing an inspection, all we can do is find a defect that has already occurred. What we want to do is, as much as possible, prevent defects from occurring in the first place, because that results in some type of scrap or rework. The Plan, Do, Check, Act cycle was developed by Short and modified by Deming, also called PDCA. It starts with a small plan. We're looking at specific requirements. What are we trying to improve upon? And we're going to try to look at, well, how can we make this a little bit better? And then we're going to go ahead and execute that plan that we come up with. From there, we want to check and see, did we have a positive or negative impact? Or did we have no impact at all? And then we go ahead and we take some type of action. And this can result in further planning or deciding that, well, this is sufficient for the time being, and perhaps start looking at different aspects of the work being done. The cost of quality is a very important concept that you will likely see on your exam. A cost-benefit analysis is very important to show stakeholders exactly how much they're going to benefit from paying for these quality activities. This is kind of like getting an oil change in your car. It is a very thankless task. Nobody will send you a rebate check at the end of the year, and nobody's going to thank you for maintaining your own vehicle. For that reason, stakeholders that are unaware of the benefits of an oil change may choose to skip doing so. However, with the cost of quality, the heuristic is that you're going to be paying at least 6 times as much for nonconformance as you would have paid for conformance. Instead of paying $26 for an oil change 4 or 5 times, you're now paying $2,000 to have your engine flushed. It's in less rework, higher productivity, lower costs, and increased stakeholder satisfaction. By demonstrating this to the stakeholders, they're going to be willing to pay the cost of conformance. Within the cost of quality, we do have two main categories, the cost of conformance and the cost of nonconformance, each with two subcategories. Within the cost of conformance, the first subcategory is the prevention costs. This is to prevent bad things from happening. So we should have a training program and ensure that all of our practitioners are aware of what they're supposed to do and specifically how are they supposed to do it. If we don't train them properly, then we cannot realistically expect them to do the job correctly. We should be able to document processes. We're going to see a process flow chart in the next couple slides. Every process should be documented. If you cannot document a process with a process map, then that means that you are unable to articulate the process. If you cannot articulate a process, that means you do not understand the process, which means, honestly, you just don't have a process. You're basically at that level 1 of CMMI where you're making it up as you go. You need to ensure that you have the right equipment. Otherwise, you have a situation that arises that's very similar to Maslow's hammer, where if all you have is a hammer, everything starts to look like a nail. Can you get the job done? Can you be effective? Perhaps. But are we introducing the possibility of creating defects? Absolutely. And we need to ensure that we're giving people time to do the job correctly, time to do it right. If we rush people, quality will suffer. If they have a 6-hour job and we give them 2 hours to do it, they will take shortcuts, they will circumvent processes, and they're going to deviate from the checklists that we give them. A second subcategory is appraisal costs. This is where we'll be doing our testing and inspections of our deliverables, and also, in some cases, in some industries, destructive testing loss. This is very common, especially in the automotive industry, perhaps is the most popular example. However, Underwriter Laboratories also does a number of destructive testing loss. So almost any time you have an electronic device, it's tested to ensure that it has certain criteria, that it's not going to catch fire by being plugged in, things along those lines. Now, if we do not pay the cost of conformance, we're going to end up paying the cost of nonconformance at some point. The two subcategories here are the internal and external failure costs. An internal failure is when we caught it before it got to the customer. An external failure is where the customer catches it. So if we catch the failure, if we catch this defect, we have an ability to go ahead and do some degree of rework if we can to make it conform. If we cannot make it conform, then we have to go ahead and scrap it. Now, if this unit gets to the customer, it is now an external failure. This is where we can have liabilities that we could be facing. In some situations, we may have to go ahead and do refunds. We may have to pay money back. We may have to do warranty work. We may have lost business. Think about any time that there's been a major recall. How many people are eager to go purchase the next product that's released by that manufacturer? Within data representation, we could use flowcharts, which we'll see an example of pretty shortly. A logical data model is where we identify data integrity or other quality issues by using plain business language for all of our organizational data after we've removed technology. With matrix diagrams, we're trying to find the strength of relationships amongst different factors, causes, and objectives. Now, the rows and columns of the matrix could take different shapes to go ahead and determine this. One popular example is a roof shape, such as the house of quality. The testing and inspection planning will help us determine how we are going to test or inspect to meet the needs and expectations of the various goals for performance and reliability that we will be inspecting for. So with software, the alpha and beta testing. For construction, it could be a strength test, and this could not just be the end result, it could also be for the components going into the deliverable. So perhaps we start testing the concrete before we lay it into the foundation, and that could be a very iterative process as we're doing inspections on the things going into our construction project. Manufacturing inspection, if we have a number of deliverables, we may have to settle for a sampling strategy, and also engineering non-destructive testing. Here we see an example of a process flowchart. We're doing some quality testing. If we identify a defect, then we need to identify the source of that defect and ask, is this a design flaw? If it is, we'll do an engineering analysis, develop an engineering solution, and send it to management for review. If it's not a design flaw, is it a process flaw? If yes, we'll do a process analysis, develop a process solution, and send to management. If it's not a process flaw, then we may need to develop another type of solution for management to review. Management will do the review. If the solution is not approved, then we need to go back and look at another source, Perhaps we have another root cause of the issue. If it is approved, we can deploy it to production. If no defect was identified, we can deploy it to production. This is a very generic process flowchart. Anytime you see a diamond, it's a decision point. Anytime you see a rectangle, it represents work actually being done. Here we see a SIPOC model. With SIPOC, we're basically looking at the suppliers that give us our inputs to our processes. So all of our inputs, everything that we need before a process can proceed, come from somewhere. We need to identify these suppliers. Then we need to look at these inputs and how they go into the process. Now we do have a feedback loop so we can go ahead and communicate with our suppliers and let them know about any further needs that we have. The outputs from the process will go to a customer or to another process. And again, we do need to identify another feedback loop. This feedback loop allows a degree of organizational learning to make this process better and more effective. Outputs from this process include the quality management plan, which explains how the project team will implement the quality policy. We also have quality metrics, which describe the product or project attributes that will be measured and how they will be measured. This could be defect frequency, failure rate, reliability, or sometimes defects. Defects per million opportunities tends to be a very popular one, DPMO. We could also have project management plan updates, including the scope baseline if we have to add work for these quality activities. Our project documents updates, including the stakeholder register, requirements traceability matrix, if we do have specific quality requirements that we must include, the risk register, and lessons learned register. We've just finished discussing the plan quality management process. Quick learning assessment. Describe the purpose of this process in your own words. We're trying to define the quality standards and the approach that we're going to be using to achieve them within our project. Give an example of a quality metric. So it could be defect frequency, reliability, defects per million opportunities, or failure rate. What is the difference between quality and grade? Quality refers to the inherent characteristics that fulfill requirements, whereas grade is a category that refers to some type of different technical aspect separate from the actual quality. What types of EEFs and OPAs are important to consider here? EEFs could include industry or government standards, regulations, operating conditions that may affect quality. OPAs could include any type of organizational quality policies or guidelines that we may have, along with goals or perhaps lessons learned from past similar projects.